Okay, so Stephen's going to show that 1 over r minus 1 over r plus 1 is equal to...
First, we rationalise the denominator, make the denominator the same. Is it rationalised or...?
Rationalise it if we had these as surds.
Okay, never mind that.
So we're making the common denominator.
Okay, yeah, common denominator, that's the one.
Okay, so what do we multiply this one by?
Well, the numerator we multiply by r plus 1.
So this will be r plus 1 all over r,
Yeah, so
r plus 1. Yeah.
And minus r over r plus r plus 1.
Yeah.
And then, yeah, you can work it out from there. You get 1 over r times r plus 1.
Yeah, pretty simple. R minus r. 0, so we get 1 over r plus 1 as required. Okay. Now what is important here, and the reason why I've asked you to do this, is that we've got a fraction here, a singular fraction, and we have managed to, we've shown that this is the equivalent to these two fractions, one subtracted from the other. Okay. Now in Core 4 you'll learn a method of how we can go from that fraction to these two, but for FP1 all we're worried about is, okay, part 1 of the question would be show that the left hand side equals the right hand side. Okay, because this is going to help us find formulas for some really quite complicated sums. Okay, so this is the sum which we're going to investigate finding, and it's what the fractions is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4, so on and so forth, and we want to add up n terms of them. Okay, so this is the first term. Now r represents the number of the term which we're dealing with. For this one, r is 1. For this one, r is 2. For this one, r is 3. And for this one, r is n. Okay, so we're adding up n terms. Can anybody tell me what the general term would be? What would the general term be? We know the nth term is 1 over n times n plus 1. Can anybody tell me what the general term is going to be? Any ideas? Mez? Yeah. The general term is 1 over r plus 1. Because r is going to be, could be anything. Okay. Now, how could we write this entire sum far more succinctly using the notation we know? Sigma 1 over r plus 1. Now, what are our limits? Well, it's going to be from 1. How many terms are we doing? N. R is a general term. R could be anything, but we're summing up to n terms. Okay? So hopefully this is a kind of illustration of what R is, what n is. R could be any number. N is the specific nth term. Okay? At GCSE you had this thing called the nth term. In A-level, the nth term is the last term of which we're trying to deal with. The general term is the rth term, if that makes sense. The rth term. Okay, so here's the general term. R varies from 1 to n, and we want to add this up. Now, we knew from our starter, if you like, that this is actually equal to 1 over r minus 1 over r plus 1. We want to find a formula in terms of n for what this sum is going to be. Okay, so this is our clue. There's our formula. Now we're going to write it as 1 over r minus 1 over r plus 1. Okay. So what we're going to do now, we'll put a line down there, and I'm going to work out the first term. I'm not going to write it as a complete fraction. We know that the first term is going to be 1 over 1 times 2, which is a half. But I'm going to write it as these two fractions subtracted one another. Okay? Here we have 1 over 1. Our first term, according to this alternative way of writing this sequence, is 1 over 1 minus 1 over r plus 1, in this case is 1 over 2. Okay? And that still gives us a half. So that's not a problem. I'm going to write the second term when r is 2. Now this is going to be 1 over 2 minus 1 over 3. Okay? And that does indeed give us a sixth. Okay? Because second term we know is 1 over 2 times 3, which is a sixth. We're just writing that sum in a different way, okay, by using this subtraction. I'm going to work out r is equal to 3. And I get 1 over 3 minus 1 over 4. By substituting r as 3 into here. Stephen, what do you notice?
The second part of R1 can cancel with first part of R2, and then like second part of R2.
Yeah. Now remember, we're adding all of these terms together. And you can notice that they've got this minus a half, add a half. These are going to cancel. We're going to get minus a third, add a third. These are going to cancel. We're going to get a lot of cancellation there, which Sam's face, it's elegant, okay? But how much cancellation are we going to get? We need to work out the last term when r is n, okay? We've worked out the first 3, now we need to work out the last 3, okay? Now, it's 1 over n is going to be 1 over n minus 1 over n plus 1. What's the penultimate term? What is r going to equal then? N minus 1. And this will be, I'll probably give myself a bit more space to write this. This will be 1 over n minus 1 minus 1 over what? If r is n minus 1, what's this second fraction? N. Good. In fact, I should have given myself a lot more space here. Take that all the way down. And I'm going to work out, just for the sake of symmetry, I've worked out the first 3, let's work out the last 3. R is n minus 2, we get 1 over n minus 2 minus 1 over what? N minus 1. Now, this is remember, we're adding all of these terms up because it's a sum we're trying to round up. This is one of the most elegant methods you're ever going to find. I mean, what happens? Can anybody describe what's going to happen? Regan.
It's going to be 1 minus 1 over n.
That is the answer. What can anybody explain why? Matty.
Because the way they cancel like the negative and the positive on each next term just leaves you with the first and the last half.
Yeah, look, the negative half cancels with the half. The negative third is going to cancel with the third. The negative quarter, now I haven't written it down, but that's going to cancel with the quarter there. And we're going to get all of this cancelling out. The n minus 2 is going to cancel with the 1 minus n minus 2 there. The minus 1 over n minus 1 cancels with the plus 1 over n minus 1. The minus 1 over n cancels with the 1 over n. And all we're left with is this bit here at the top and this bit here at the bottom. They're the only things which do not cancel. So that entire sum, has basically reduced down to, so it's the sum from 1 to n of 1 over r minus 1 over r plus 1 has basically reduced down to the formula 1 minus 1 over n plus 1. Okay? Now in turn, remember our original question was 1 over r plus 1. And this again is going to be equal to 1 minus 1 over n plus 1. Okay? The original question is 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus all the way up to 1 over n times n plus 1. That is going to be equal to 1 minus 1 over n plus 1. Okay, we have worked out the formula for this rather complicated fractional sum. We have worked out the formula. That's what it is. We've worked out the formula for what happens when we add up all of these terms. And it's an incredibly beautiful and elegant method where we work out the first 3, work out the last 3, we notice there's some cancelling out, and what are we left with? We've left this 1 over 1, which is 1, and we're left with this minus 1 over n plus 1. So the formula is 1 minus 1 over n plus 1, which is incredibly elegant. They call this telescoping sums. If you think you've got a telescope, it's very small, then you can extend it out. Okay, so here we've got a massive sum, and we kind of telescope it into something very small because everything all cancels. And here we just cancel with the one term at the beginning and one term at the end. Incredibly powerful. The other way they call it, the other words which they've used, which are probably, I remember it as telescoping sums, but I think it's commonly used now as method of differences. This is what we call, I don't think it sounds a lot better than telescoping sums. It's quite a visual idea of what you're actually doing here. It's called the method of differences because your sum, your original sum, is rewritten, so it's the difference of two fractions written together. Okay, let's do another one. I think you are laughing if you get one of these questions in the exam, because I think that the method is there's very few surprises they're going to ask you here. So